Welcome. In this video we'll be analyzing function notation with exponential functions part 2. Let's take a look at our first example. Example 1. Given f of x is equal to 5 to the x minus 4, find f of negative 3. So what we're going to do here is to substitute in our input value of negative 3 for x. By doing so we get f of negative 3 is equal to 5 to the negative 3 minus 4. Now keep in mind that 5 to the negative 3 means that we have 1 over 5 cubed. And 5 cubed is the same as 5 times 5 times 5, which simplifies to 125. So 5 to the negative 3 is the same as 1 over 5 cubed, or simply 1 over 125. Now using this information we can say that f of negative 3 is equal to 1 over 125 minus 4. In this case we are going to use a common denominator so we can combine both of these numbers. So we have that the common denominator will be 125. So we write 1 over 125 minus 4 times 125 over 125. So we have that f of negative 3 is equal to 1 over 125 minus 4 times 125 is 500, all over 125. So we get that f of negative 3 is equal to 1 minus 500 gives us negative 499, all over 125. So that's the value for f of negative 3, negative 499 over 125. Let's see a couple more examples. Example 2. Given g of x is equal to 7 to the x plus 6, find g of negative 2. Once again, let's substitute in our input value of negative 2 wherever we see an x. So we have that g of negative 2 is equal to 7 to the negative 2 plus 6. Now keep in mind that 7 to the negative 2 is equal to 1 over 7 squared. And recall that 7 squared is the same as 7 times 7, which is 49. So 7 to the negative 2 is equal to 1 over 7 squared, or simply 1 over 49. Now using this information we can rewrite g of negative 2 as follows. G of negative 2 is equal to 1 over 49 plus 6. Once again we need to find the least common denominator so we can combine these two numbers. In this case the least common denominator happens to be 49. So we have g of negative 2 is equal to 1 over 49 plus 6 times 49 over 49. So let's multiply the 6 times the 49. 49 times 6 will be worked out over here on this side. 6 times 9 gives you 54. We carry the 5 over. And then 6 times 4 is 24 plus 5 gives you 29. So 6 times 49 is 294. Now using that information we can say that g of negative 2 is equal to 1 over 49 plus 294 over 49. Now combining like terms we get that g of negative 2 is equal to 1 plus 294 gives you 295 all over 49. So we can say that g of negative 2 is equal to 295 over 49. Let's see one last example here. Example 3. Given h of x is equal to 8 to the x minus 14, find h of negative 1. So what we're going to do is to take this negative 1 as our input value and substitute in wherever we see an x. So we can get the following. H of negative 1 is the same as 8 to the negative 1 minus 14. Now keep in mind that 8 to the negative 1 is the same as 1 over 8 to the first power. And any number or any non-zero number to the first power is the number itself. So this is just 1 over 8. Using this information we can write the following. H of negative 1 is the same as 1 over 8 minus 14. Now looking for the least common denominator we realize that that happens to be 8. So we can rewrite h of negative 1 as follows. 1 over 8 minus 14 times 8 over 8. Now let's multiply the 14 times the 8. So we have 14 times 8. 8 times 4 is 32. We carry the 3 over. 8 times 1 is 8 plus 3 gives you 11. So 14 times 8 is 112. Using that information, we have that h of negative 1 is equal to 1/8 minus 112 eighths. Now combining these terms, we get that h of negative 1 is equal to 1 minus 112 is negative 111 over the common denominator of 8. Thus, you can conclude that h of negative 1 is the same as negative 111 over 8. And that concludes this video on function notation with exponential functions, part 2. Thank you for watching and have a wonderful day.